I think I'm to a point where I really need to start learning how to say no. So this is a really exciting video because in this box I've got an Infimech TX 3D printer, which doesn't sound like much to anybody, but the Infimech TX is actually the first Core XY 3D printer that I'm going to be reviewing on this channel. The Infimech TX is a fully enclosed Core XY 3D printer that runs Clipper firmware and is capable of advertised print speeds of 500 millimeters per second at 20,000 millimeters per second squared of acceleration. It features a 220mm by 220mm by 250mm print volume, a 12.5:1 ratio direct drive extruder, 8mm diameter hollow shaft linear rails for reduced weight, a CNC machined aluminum frame, an all-metal hot end with an off-the-shelf volcano nozzle capable of 300 degrees Celsius printing temperatures, and 40 cubic millimeters per second of maximum material flow. It's got dual independent Z-axis motors for automatic tilt compensation, and an available accessory kit with camera, auxiliary blower for even better cooling, and an active air filtration system with carbon filter. So a little backstory is that 5,000-ish subscribers or so ago, I had reached out to a company called Flying Bear to try to get one of their Reborn 2 Core XY 3D printers, and after a whole bunch of back and forth, I never did receive one. But Infimech is actually a rebranding of sorts for Flying Bear in the US market. So this Infimech TX is actually a Flying Bear S1, which is still a brand new product for that company. It's a Core XY Clipper printer. It's got a whole bunch of little features and niceties that I want to go through. So I'm going to do an unboxing and review of this printer, and we'll see what happens. Okay, so inside the box we have a little instruction manual. It's actually not very large because this printer actually comes about 95% pre-assembled. All you have to do is put on the front door, I think. And then we've got a cover inside of this slippity-dippity here. This is actually a cover that goes over top of the unit to protect the gantry, but also to prevent heat from escaping. And if you're printing filaments such as ABS or ASA, this will kind of keep the fumes in. Chinese checklist here to make sure that everything is on the up and up prior to shipping, which is a nice touch. This kind of reminds me of the machine tool company that I used to work for prior to about a month and a half ago. We would supply a checklist that went over every single item to make sure that everything was okay and that it was accurate and that all of the parts were included. So it's a nice touch that they give you that. Well, here's the machine. I'm going to get it out of the box and get it up onto the table, but it is packaged very nicely, I do have to say. It's got corner protectors, and then it's encapsulated in this foam. The handles on the side of the box are open, but the printer itself is actually wrapped in plastic to prevent any kind of contaminants from getting to it. But I'm not working in the largest space, so just bear with me. All right, so I got it out of the slippery plastic and I got it up onto the table. And aside from a little divot that I put in my wall that we're not going to talk about, initial impressions, this is a very impressive looking machine. It's very well built. It's mostly assembled. It's got this door on it that has a couple of magnets here. And snaps in place when you close it. It's nice. So fit, form, and function, I'm going to say, oh, and it's glass too. It's not even plastic. It's actually a glass door. You can tell because it hit my watch. There's a couple of pieces of foam on the inside that I still have to remove. And it's got some zip ties on here because the shroud is actually held on with magnets. So you could take the shroud off without having to unscrew anything here. It just comes off because of the magnets, and then you can access the hot end and the nozzle and all of that. From what I've gathered, this appears to be an off-the-shelf volcano style nozzle, so nozzles should be readily available for this machine, which says a lot compared to a lot of the machines that are coming out lately with the proprietary design, so that's definitely a +1 for that. Okay, so that's kind of nice. They put all of the accoutrements inside of the machine, inside the protective foam that they use to keep the Z-axis from dropping. They give you a pretty significant test spool of filament. Hey, there it is, the Flying Bear logo. So they're not trying to hide it by saying that we're Infimech. We're actually Flying Bear. And it comes with the usual. It's got zip ties, cutter, a scraper, USB stick, some tweezers, that's cool, nozzle cleaner, and then what appears to be a calibration cube that I'm assuming was printed on the machine. And then here we've got the usual suspects, Allen keys, some mounting hardware, and then inside of this package, we've got the simplest luxury handle. You see right there, the simplest luxury handle. So hell, if this is an off-shelf item, maybe I'm going to remodel my kitchen with these as well. Customized for the whole house. Hell yeah, you could actually buy these. I guarantee you can get these for kitchen cabinets. I'm 99% positive. Here we've got the IEC cable, filament holder, and last but not least, if I can get it out of the foam, the capacitive touchscreen that mounts down here. The screws for the screen already come inserted. It's just a matter of putting these in here and attaching the cable for the screen right here. So the screen that they're using is a 4.8-inch capacitive touchscreen, and it's actually a TJC 4827X23 model. Now, I don't know if you're familiar with next-gen HMI displays, but TJC is basically the domestic Chinese market next-gen display, and that's actually a point of contention in the Arduino development market because the TJC screens are like half the price of a next-gen, but next-gen won't allow TJCs to be imported here and use the same IDE, blah, blah, it's a whole thing. So looking at the inside of the machine so far, you've got a USB port right here, got power switch right here. It's got dual independent Z screws. It rides on these round linear shafts with bearings in all four corners. It's got a little instruction on how to get everything assembled right here. The build plate actually resembles the Creality Ender 3 V3 SE, where it's got the two notches in the back here for alignment. And I'm actually going to try something out here. Wait, hold on. Let's just see for... Now, see, it's a little different. It's a little bit different. So the Ender 3 V3 SE hole spacing for the pins is a little bit different, and the build plate is slightly smaller. You can see right there. Thank you, Wham Bam. So it's PEI coated. It says apply glue before printing. We're going to scratch that off. But again, this lines up with the pins and drops right into place, which I always thought was a nice touch on all these printers that are coming out nowadays. Those alignment pins are by far better than what I was getting with the with those Neptunes. So they definitely take their time with packaging. A whole bunch of little foam pieces that you have to remove. So then the Bowden tube inserts into the top here. Make sure you get all your zip ties. And it was at about this time that the batteries in my microphone died, so I'm just going to voice over this part right here. Take the two screws with the blue Loctite on them, and those are the screws that are used to put the door handle on. On the back of the machine, we've got the provision for the IEC cable, an Ethernet port for wired Ethernet connection, the filament runout sensor, and then the hole where the filament spool is going to mount. It screws in with the provided nut, so just put the spool holder into the back, reach in and take the nut and basically just screw it in place and make sure that it's tight. From there, we just mount the capacitive touchscreen on the front with the two screws and the cable that are inside the cabinet. And once that's done, we can plug the machine in, power it on, and we're ready to go. Well, I guess I'll find out in post how much I missed of my voice recording for this video. So I've got it on the table, I plugged it in, and we're ready to power up. So let's do the honors. As I mentioned, capacitive touchscreen, fancy schmancy door handle. It's got rare earth magnets here and here. And there are some accompanying magnets or metallic strips inside the door. They're held on with a foam-backed adhesive, like a tape. Not sure how long they're going to stay in place, but time will tell. So let's fire this baby up for the first time. So the first thing it does is it goes into a setup mode, and it's going to ask you for the language. It's going to ask if you want to do Chinese, English, or Russian. In this case, it defaults to English. And by the way, I did forget to mention that there is a power selector switch on the power supply, and I removed the side cover just to make sure that it was set to 110, but it was from the factory, so I didn't have to worry about it, but just keep that in mind. So anyway, when you first fire it up, it brings you to this menu, and it says choose your language, Chinese, English, or Russian. I'll hit next because it's already defaulting to English, and it says please remove the nozzle zip ties, clean up any excess packaging materials. And it shows you right here all the foam that got removed. And once you're clear of all the foam and you've removed the zip ties from around the hot end, hit next. And again, it just reminds you, make sure you take off all of the nozzle zip ties, clean up any excess packaging materials. Make sure that that foam is gone. The next menu asks you for your Wi-Fi. You could skip it right now if you wanted to, or you hit next after you choose your Wi-Fi network. It will prompt you to put in your password, and then once you do that, it goes into a self-temperature calibration, resonance compensation, and auto-leveling procedure. Okay, so you have to give it about 20 minutes for it to run through the initial calibrations, so don't be alarmed if it seems like it takes forever. It does take quite a while. It takes about 20 minutes, like I said. But it goes through all of the different checks. It makes sure that the bed is leveled. It makes sure that the Z-axis is straight because it's got dual independent Z-axis motors. Picks up a bed mesh. It does automatic Z offset, and then it's got built-in accelerometers, so it does all of the resonance testing all by itself. And then when it's done, you get a little welcome screen. You hit confirm, and then we get to the interface. Looking at the interface, it looks like we've got a gear. And then the gear is the setup page, and it lets us change the language. If we go to this little guy here, we can scan the QR codes to get the latest firmware and to access product tutorials. The power icon lets you do a restart of the firmware. The information icon shows you the current running firmware version. It shows you the input voltage. It shows you filament dimensions. Basically gives you a rundown of all of the different features of the machine. And then we could do a factory reset or the firmware update. That's the back button. If we go to this page, we've got axis movements. We've got X and Y home, all home, motor off, and then going down the line, we've got 1 millimeter of movement, 5 millimeters of movement, and 20 millimeters of movement, which is a little unusual. I'm used to seeing 10 millimeters, but not 20. Here we've got the cooling button to turn everything off, and then we've got our nozzle temperature, bed temperature. We click on one of those, we can set the temperature for the nozzle, for the bed. And again, we've got home all, so let's do that real quick. So it kind of gyrates a little bit when you home it out, and it actually does it again. So here it is. It just kind of like gyrates the table. I don't know what that's supposed to accomplish. Maybe that's to make sure that after a bunch of Z movements, it's consistently zeroing out, but I guess time will tell. And then once it's done homing, it drops the Z down, gives us some room to work. If we want to move the machine around, we can select the resolution, and then we can do a Z minus. And again, drop it down by 20 millimeters per click. Going down the menus here, again, we've got the axis motion, which is the page that we're on now. Here we've got filament, so we can load and unload filament. The gear lets us do temperature calibration, resonance compensation, and auto leveling. Then the Wi-Fi button lets us switch Wi-Fi networks, hit the back button, and then this guy here is for turning on the internal LED. It's got a pretty nice LED light on the inside of it. And then it's got controls for the secondary features that you can buy, the auxiliary blower fan, and the air filter fan. And then we could set up video recording right from here, so we can plug in a camera to the USB port. And then back on the main page, if we go to this icon here, this is where we can choose our print files. So I don't have any print files uploaded to it, but here we've got files that are uploaded, files on USB. Now it does come with a USB stick, so I can plug that in and see what it's got. You can see there's a couple of different files. Here we've got what looks like a calibration cube, a little Flexi Rexy Tyrannosaurus. I don't know what the hell that is. And then we've got the standard boats. You got a high-speed boat and you got a 30-minute boat. Oh, actually a 39-minute boat. And then here the high-speed boat says it takes about 13 minutes. So we're going to test that. So we'll go back. So there's not really a lot of menus to choose from. So we'll go to here and then go to Filament. And we want to load Filament. So I guess we press the load button. Once we do that, it heats up the nozzle. And I guess we should get it ready to load in because it's more than likely going to start an automatic loading routine. So the filament loads in the back of the machine, which I'm not overly keen on. I would like to see the filament spool mounted to the side of the machine, because with these rear mounted spools you have to spin the entire machine around, and if you have a bunch of these in a farm, it's not really the most conducive for that type of setup. So I do have a spool on the back. Doesn't really have a lot of filament. I was just testing out to see exactly where it fell in on the back of the machine. But for right now, I'll just use that. So I got my trusty snips. I'll cut a 45 on the end of the filament. That's usually the way to go. And so for this test, much like all my other tests, I'm going to use my trusty Kinlowatt red PLA. I'll snip the quintessential 45-degree angle on the end of the filament, and I'll load it into the sensor. Okay, so right off the hop, I'm seeing that this sensor is not really the greatest. You really got to play with it. I don't know if there's a trick to this, but it doesn't really like to load, really. All right, let's try a different 45. Hey, there we go. So it's not a 45, it's a 135. Okay, I've got it in position. I think I missed the boat for the automatic load, so I'll have to spin it back around. All right, I'll try to load again. So the gears are spinning. Grab the filament from the back and push. And I could feel it grabbing and pulling itself in. We've got a little bit of spit out here, so that means I've got filament loaded. And then you can switch between manual and automatic by changing this button right here. So I'm going to go 5 millimeters in the reverse direction to kind of get the pressure off of the nozzle so I don't have to pull on these wispy strings coming off of the filament. Okay, so I've got filament loaded. I've got files on here, so I'm going to start a print. Let's see what it'll do. But before I do that, I just want to point out that the machine does come with a top cover, and it comes with this little thing here, and the thing goes inside the cover, and it just lines up with the Velcro that's in there, and it kind of gives it a stiff backing so that it makes it more rigid. And then the cover sits on top like so, and there's a Velcro strip on the back that attaches to the Velcro on the back cover, and two little dog ears on the side. I'll pan up, I'll show you. So you can see that. It kind of looks like a Russian. All right, so here we go. Go back, go to print, print off of USB, and let's choose the high-speed boat, as much as I love boats. And then we'll hit go and just see what it does. So it does run through a little bit of a startup procedure. It did a purge at the very front of the table, so there's a red booger hanging down. Now it's doing the automatic table adjustment. And there we go. It actually sticks quite well to the sheet. So I'll take it out, let it cool off for a second. Well, here it is. Now this is the 13 minute, and it takes 18 minutes because it goes through about a 5-minute startup process. But, I mean, looking at it, it's really not horrible. I mean, it's a boat, so it's horrible by default, but even with just the standard cooling, there's a little bit of a defect here on the front, but otherwise, aside from a little bit of stringing inside of here, it doesn't look terrible. I mean, it's a boat-shaped thing, so the top spout looks good. The bridging inside of the window there, it's hard to tell because I'm trying to look through my camera viewfinder, but it doesn't look horrible for a 13-minute boat. The auto Z offset kind of wiped out all of the lettering. It is a little too close to the bed surface. I'm not sure if there's a way to adjust that. I didn't really pay much attention to the screen to see if there was a way to bump up the Z offset after it did the automatic calibration. So that's my bad. I'm gonna have to run another print and just see if that actually is the case. But as you can see, the thing moves around like a bat out of hell. This is a very fast machine. That's the fastest setting that you'll probably find will be that boat. But I'm going to run another print and I'll see what the accelerations are with that one. So I just started the print on the standard speed boat, and it does not look like there are any kind of Z offset adjustments, so you're kind of at the mercy of what the machine gives you at that point. It does have heat override for the nozzle, for the bed. It's got speed adjustment, extrusion adjustment, and then under more, it's only got the controls for the LED and things like that. You can see it's doing its little purge operation here. So I'm just going to let this run, and we'll come back and see what it looks like. Okay, so as you can see, this one's a lot better. This is the standard speed boat. There's no stringing. The bridging in the window here is a lot better. The front has no sign of distortion. It's still a little heavy on the Z offset on the bottom. And it's kind of hard to make out the text that's on the back here. But otherwise, I would say that this is a really good boat for not having to do any setup or calibration on this machine. It's all pretty self-contained. I haven't found any adjustment for the Z offset yet, but maybe that's something that we'll find in the fluid interface. So one nice thing about this machine is that the little pup tent can easily be removed by simply pulling the Velcro straps and then just lifting it up. You don't even have to remove it from the machine itself. You can just kind of fold it back and it just rides back here and you can do whatever you need to do. When it comes to the hot end assembly, being that the shroud is up on magnets, all you got to do is just pull on it and you can do all of your maintenance. You can change out whatever you have to do. There's a couple of wires that hold the blower fans in place, and then it just snaps back on. The one thing I don't like about it is that it's this smooth, kind of shiny plastic. I think it would have looked a little better if it were kind of crackly and this window here were kind of smoked a little bit. I mean, you could see the filament path inside of here, but I don't know. The smooth just kind of cheeses it up a little bit. But they're using what appear to be the, I guess, Kevlar reinforced, if you will, or some kind of fiber reinforced belt. You can see by the red hue on the inside with the teeth. Still a GT2 style belt, 6mm. A lot of the frame parts are all heavy-duty extruded aluminum, but the Z-axis and all of the gantry parts are injection molded plastic, which shouldn't be an issue. The one thing that I did find moving this thing around is that they have the x-axis because everything's riding on a 45-degree kinematic, but x-axis is set for 230 millimeter, but if you try to go to that 230 millimeter, it kind of it hits on the far right side, so just be careful with that. Might have to tweak that limit back a little bit. I removed the bottom cover and I laid the machine on its side, obviously, but I wanted to get a look at the main board that's running. We can see right here underneath these wires, it's an MKS Skipper Mini V1.0. So this is just a smaller version of their Skipper board, which is an integrated Linux device and printer MCU in one, similar to the Big Tree Tech Manta board or even the Elegoo ZMP K1, but it's essentially a Skipper, just in a different package. But now this is an interesting board because it's got a couple of unusual characteristics about it. As an example, it's got removable motor drivers, which a lot of the Skipper-esque boards, the Linux device type boards, are coming with the drivers soldered in place, which is kind of cool because this might be conducive for some modifications down the line. I've got a couple of closed loop MKS stepper motors and drivers that might actually fit on this board, so that might be something that I'm going to have to kind of dig into in the future. And it's got the bog standard MKS eMMC V1.0, 8 gigabytes, which is never enough on these boards. The 32 gig version is only a few bucks on Slamazon, and it would just be a matter of putting the firmware onto that board as opposed to the 8 gigabyte one that comes pre-installed. It does have what appears to be the telephone jack output for the MKS H43, or if you really want to get into it, it's probably compatible with some of the other printers that I have because MakerBase is making a lot of the boards for these other companies as well. It's got the Ethernet jack right here, and then it's got a jumper wire that goes to the back for the actual Ethernet plug-in for the end user. It's got an additional USB port right here that is not being utilized, but I'm sure is available. I'm sure that the drivers are installed for it. Here we've got the USB going out to the top of the electrical enclosure on the inside of the machine, and that's the USB 3.0. It does have the USB-C for serial debugging. It's got an SD slot right next to that for firmware updates. It's running an STM32F402 chip, so it's very much the bog standard for these type of boards. And if we zoom back a little bit to the spaghetti incident that's going on here, we can see that it's got dangerous voltage going to it because we've got the power switch that is inside the machine getting tied to the IEC that's incoming. Not really seeing anything out of the ordinary here. So if you look down here, there's a plug for what looks like the accelerometer because we got 3.3 volt CS, MISO, MASI, and SCK. And I'm assuming that that is for the accelerometer that's on the head. Here we've got incoming DC voltage from the power supply, single voltage power supply, so it's not dual voltage. The artilleries that I've been working on have 24 and I believe 36, if memory serves me, voltage capacity on power supply. This is just a single power supply, 24 volt. And then the heat bed, again, 24 volt coming out here. They've got ferrites on motor wires to eliminate any kind of EMI. But aside from that, it's pretty standard issue stuff. I would like to run a jumper for this USB port out to the outside of the machine just to have access to it in the future. It would be useful to have. Now, the one thing that I have noticed about these boards in general and all of the products that I've received over the past year is that nobody ever takes off this little seal here for the buzzer that's on these boards. Oh, and another thing, I did mention earlier at the beginning of the video that I thought that the feet were 3D printed, and lo and behold, they are 3D printed and they are TPU. That's kind of nice. I like that. I mean, hell, if Prusa is doing it. So for the sake of my own morbid curiosity, I'm going to try to connect this to the Big Tree Tech K-Touch. So go to Add Printer, manually add printer, IP address 192.168.1.23 and port 7125. Hit OK. Select it. Choose it. Switch to it. And there we go. I even got it on the Big Tree Tech K-Touch. So I can go to Axis Temp. I'll do a home all. So it even works on the Big Tree Tech K-Touch with no problems whatsoever. Connected right to it. And this is nothing more than a small tablet with their own proprietary interface over top of it. So I don't see this not working in any way, shape, or form. So that's good. So the one thing to keep in mind about the Infimech TX is that it uses Orca Slicer as its default slicer, and there are profiles already available online for the Infimech TX. You don't have to install any special versions or anything like that. You just install bog standard Orca Slicer, and you search for Infimech, and they come right up. There's one for the standard nozzle and one for a hardened steel nozzle. And even if they didn't have one, it's the exact same machine as a Flying Bear S1, so you could probably use that profile and get the same result. I'm going to add that just in case. I just want to see if there's a difference between the Flying Bear and the Infimech. I'm going to run this Voron cube just because that's something that I tend to run on every printer that I test out. And just from looking here, if I go Flying Bear back to Infimech, transfer, this stuff is the same. I go to speed, check out one to the other. Yeah, it seems like they're the exact same profile. The only changes I've made to their standard profile settings are my infill. I made it 5% infill with a cubic pattern. But aside from that, this is the way that the profile came in. I already went into the connection icon and I connected the TX to Orca Slicer. So if I go to my user preset, I go to device, we can see that the fluid interface comes up because that is the interface that's installed on the TX. The one thing that I did notice is that when I tried to SSH into the device, the default MKS username is locked out, and so is root access. So they locked it out, and I don't know what the login information is for it. By default, the MakerBase boards are typically username MKS, and the password is MakerBase, but that is not the case on the Infimech TX. With that all being said, I'm going to send this over to the printer. Okay, so Voron test cube, printed out pretty nice. There are some striations in the layers, but that's to be expected with this filament. Yet again, it's the Kilowatt red, and it does tend to leave some more artifacts than any of the other PLAs that I use. But this is probably one of the cleanest Voron cubes that I've printed to date, so I'm pretty happy with that. Dimensionally, it is a little bit short in the Z-axis, so I'm going to have to take a look at that, but it's only a couple of thousandths of an inch, so it might be to be expected. They may just have the Z-axis tuned in a way that it's just to a bog standard number and they didn't really dial it in, so I'm going to have to, I'll just play with that a little bit and see what I can get out of it. But other than that, dimensionally, X and Y, it's pretty much right on the money. So I'm going to continue on with a couple more test prints, and we'll see what we get out of it. So as a side note, I printed out one of the X-axis tubes for the coordinate cubes that I make and sell on Etsy. And I do honestly have to say that by far this is the cleanest I've ever seen one of these tubes come out. So I'm very happy with the results of this, especially because it's my primary product that I print on these things. So I'm going to switch over to this white G-Tech PLA Plus because I promised that I would do a review on this as well. And I want to see how this works in conjunction with this printer. I will have to bump up the temperature in Orca Slicer a little bit for this particular filament, but I want to see the results of the coordinate cube and see if that's as clean as the tube is. And while this thing is heating up, I am going to say that the one thing that I really dislike about this machine, if I had to choose anything, it's the fact that the filament spool's mounted on the back. So I think I'm going to either be using a filament dryer next to it, or I'm going to relocate the spool over to the left-hand side. And that way I don't have to mess around with the filament sensor too much. That'll be in the back, but I'll just run a longer Bowden tube over to here, and that should rectify the issue. Well, anybody who's been here for a long time knows that I like the warts and all approach, so I figured I'd give you a rundown of what's going on here. So I'm trying to load that white PLA filament, but when I tried to unload the red filament, I had a minor snafu here and I had a clog. So I took the front cover off, which gives you access to the gears. Keep an eye out for the pneumatic fitting, because if you take the front cover off of the extruder, the pneumatic fitting comes along with it and it just kind of rolls onto the floor. So be careful with that. But otherwise, give you a quick little rundown of what I see here. You got your main drive gear here, which drives this guy, and then this one just kind of goes for the ride. But then there's a PTFE tube here that leads down into the hot end area. I haven't had to take this fully apart yet, but looking at it, it doesn't look like it would be too much of a hassle, but it doesn't look like it'll be fun. So I'm not going to continue pulling that apart unless I really have to. But the one thing that I do like is this removable shroud here. I do get a kick out of that. That is pretty nice. And if there's one bit of information that you can take away from this, is that when you have to remove all of the screws from this extruder head, make sure that you don't get them mixed up, because they are all different lengths. So while you're disassembling and reassembling, you have to make sure that they go back into the same spot, because they are 4 different lengths and they all have their own particular mounting location. Well, this is awkward. So admittedly, I did have a little bit of an issue with the white cube that I wanted to print. It's kind of hard to see, but if you look, you can kind of see where I'm getting some sagging. There was some stringing in the circle area. So this is a 3-axis cube, and it has to print these 2 circles basically vertically. So this area here has always been problematic, but this is the most that I've seen. I think it's a little to do with Orca Slicer, but I also had the makings of a partial clog, so I wound up pulling apart the entire print head, and I did find a little bit of residual. There was, it almost looked like a skin on the inside of the extrusion assembly, if you will. So I had to take that all apart and clean it all out, and then tried to load filament again, and what happened, I got another clog, so I had to pull it apart again. It was a whole thing. So after 2 attempts with the cube, I decided to just go ahead and print one of these Flexi Rexis, one of the stock prints that comes on the USB stick, and that printed with great success. So I said, you know what? Let's forego the cube, only because I probably don't know the setting that I need or what it's called in Orca Slicer, and I will just print something that takes a long time and can give me some quality results. So I printed this guy here overnight, and this took 7 hours and 42 minutes, and the actual slice time in Orca Slicer was calculated to be 7 hours and 45 minutes. So it's pretty much right on the money as far as the calculated cycle time. We can see that the quality is very good. I printed this without supports, so there's no supports at all. That's why you might see a little bit of a hangy down right here in the eyes. But aside from that, I mean, it's actually the largest thing I've printed in a long time. The only thing I've ever printed bigger than this was one of those thing hands from Addams Family. It could probably use a little bit more resonance tuning. I do see a little bit of a rippling along here, but you have to remember that the table that I'm working on isn't really the greatest, and it does move back and forth. So no matter how much resonance tuning I do on the machine, I'm never going to be able to counteract the amount of wobble that this table has, even though I spent so much money on it. I do have plans of stabilizing my shelf system a little bit better, and hopefully that rectifies the issues that I have with all of my printers being on that as well. But for now, I'm going to say that the Infimech TX is a great Core XY printer in the $300-ish range. And right now, I looked on their website, and it's currently sitting at about $309. So jump on that if you get the opportunity. Everything that I've printed with this so far has been great quality. The machine has been very reliable. The only thing I've done with the PEI sheet was rinse it with soap and water. I haven't had any adhesion issues whatsoever in all of the things that I've printed. So aside from the Z offset being slightly low and leaving a couple of ripples on my first layer on all of the prints that I've done, everything else checks out great. The surface quality is very respectable. It's some of the best print quality that I've seen from all the printers that I've had. The UI is easy to navigate. Incorporating it into a Pad 7 or a K-Touch setup, or even running it off of a tablet, is dirt simple. It's just as easy as incorporating any Clipper-based machine onto a tablet, cell phone, what have you. And ultimately, I think we've got ourselves a winner. So if you made it this far into the video, my takeaways are that if you're looking for a very good Core XY 3D printer at almost bedslinger price, or if you don't want to be locked into the proprietary spyware bullshit of Bambu Labs, the Infimech TX is a great place to start looking. I can honestly say that, without a doubt, if you're looking into speed printing, you won't be disappointed with this machine. The Clipper firmware they use, much like any other maker-based skipper-type board with the TJC HMI screen, is running a special version of Clipper to get it all working the way they want it to, and the lack of root access prevents anyone from borking anything up too bad, but you're at the mercy of firmware updates from the factory. I'm looking forward to seeing if they follow GPL license rules and release the firmware so it can be freely modified and installed on a 32 gig eMMC chip, but we'll see how that pans out. The PEI sheet they use holds incredibly well. I haven't had any warping issues or releasing of anything I've printed in the last few days with this machine, so I'm pretty confident in saying that the PEI sheet is quite good. Their interface design is intuitive and pretty easy to use. Integration with third-party controllers such as the K-Touch is just as easy as you would think it would be for a standard Clipper machine. The accessory kit is pretty much a must-have and includes all of the goodies you'd be hoping for in a printer with this much capability. The filament sensor does kind of suck, and the filament spool placement isn't really the most conducive for modern print farm setups or even someone less able to spin the machine around anytime they want to change filament. The fully enclosed chamber makes printing stubborn filaments much easier than an open-air machine, and finally, the convertible top makes it easy to do maintenance and cool off the chamber if you're having issues with low-temperature filaments such as PLA. So that'll about wrap it up for this video. If you like it, hit the thumbs up. If you enjoy this type of content and you haven't done so yet, please subscribe to the channel. And if you know somebody who'd be interested in this type of stuff, share it with a friend because sharing is caring. Check out my affiliate links in the description down below at no additional cost to you. It just puts a little bit of catnip into my kitty and it helps with my future channel endeavors. I'd like to take a moment to thank Infimech for sending me their TX 3D printer for this unbiased unbox and review. Keep in mind that all of my opinions are my own and nobody at Infimech has seen this video prior to its release. If you've got 10 seconds to kill, check out my website at www.theferralengineer.com. It's just a whole bunch more of the same stuff, but it justifies the $10 a year I spend on the URL. And finally, thank you to all of my Catnip contributors, both past, present, and future. Thank you for watching, and we'll see you again soon.